In this session, we will cover essential knowledge for web development and JavaScript-based programming. We will be focusing on JavaScript's promise, async, and await. Promise, async, and await are used to make asynchronous codes easier to understand. These are not new features per se, rather they are syntactic sugars that simplify the writing and reading of codes previously structured with callback functions. Let us examine this via some code. This code has three functions that perform asynchronous operations. Each one fetches data remotely, processes it in a certain way, and then stores the result. For the sake of our example though, we are not actually networking or saving files. Rather, we are substituting these actions with ones that each take a second to complete. On the right, we have code that calls these functions in sequence.
Why does the middle look like it has been punched hard and caved in?
Yes, as the chain of operations lengthens, the middle gets more deeply embedded. This is what we call callback hell. We will further explore this shortly. The last line prints the string start in the log, and the result that is printed resembles what I have written in the comments below. First, this start string appears. Approximately 3 seconds later, you can see the results of the three function executions print out like this.
How come the last line gets printed before the previous code does?
That is actually an attribute of asynchronous code. Imagine customers in a row ordering food at a restaurant. The first 3 people have ordered meals that take time to prepare, but the last person has grabbed a ready-made drink and is headed to the checkout. Their checkout process works like synchronous code on a single thread and is quickly underway. The first to leave the store is the customer who only bought a drink. Since it does not consume any time, even if he is behind the other customers, his result comes out first. The rest of the customers leave the restaurant as their meals get ready in the kitchen. The difference between synchronous and asynchronous code is similar to this. This console log is a regular synchronous code, like the customer who only bought a drink. But the functions on the left side are all doing asynchronous tasks, just like the customers who ordered meals that take time to prepare. Also, they wait for one order to be prepared and received before the next person orders. That is why the results are printed out in this order. Let us look at the calling process of these functions. First of all, the fetch data function is executed like this. This function assumes a value fetched from a remote server and produces such a string as a result after 1 second. This value is passed as an argument to the callback function that the fetch data function takes as a parameter. The next function is the process data function. The process data function gets the value from the fetch data function like this. Then, after 1 second, it concatenates a string like this, and then it passes this value to the next function, save data. Save data receives this value as a parameter named processed. This function receives the callback functions to be executed when the data is successfully saved and when it fails, like this. There is a 90% chance that the storage will be successful and this function will be called, and the same result as the comment will appear. If an error occurs, it is reported from the function below. For those of you who have not used callback functions like setTimeout in JavaScript, you should take a closer look at this process.
I have just run it 3 times. Is it not too counterintuitive and headache-inducing?
That is right. That is why promise and async await came into being. Some function finishes its job and puts what to do next as an argument inside. And when that function finishes its job, it repeats what to do next as an argument. The more steps you go through, the deeper the indenting of the code and the harder it is to grasp the whole context. Now we are going to rewrite this using the promise style. Here, the functions on the left are changed to return instances of a class called promise. Literally, it is a promise that each function will do something after a time-consuming task. The code to chain these calls has changed, as you see on the right.
Has it not become really neat? Something like method chaining or something?
Yes, that is right. You can more easily understand how each task leads to the next one. Let us go over it in order. When you run this fetch data function, you get a promise instance like this. You can think of it as a written promise of what to do. This resolve stated in the promise means what to do when the time-consuming task is successfully completed. In other words, it is a promise that, if things go well, I will carry out this mission. That task is to run the next function, the process data function, with the obtained result. The then method of the promise instance takes as arguments what to do when the promiser's task is successful or failed. The first argument callback function is what to do when the task is successful. The then method returns the value that the promise it is attached to returns. You can see that it is also another promise, like on the left side. That is, once one promise is fulfilled, another promise is made as a vow. The value acquired from the previous promise is used in this way, passed onto a new promise. After 1 second, it will add the string as shown here and pass it on to the next task. In this vow, the resolve executes save data, much like on the right side. And then the next promise is returned and executed by then, as you can see here. This promise instance takes 2 parameters for the function received as a constructor argument. One is similar to the promise shown above, what to do when the current task is successful. Therefore, if the data save is successful, it is passed as an argument to then, and the concatenated string is printed out like this. There is a 10% chance that the save will fail, and if it does, the catch method is triggered through reject. So when using promises, you handle errors with the catch method like this after chained then method calls. Lastly, regardless of whether an error occurs or not, you can pass something to do as an argument to the finally method like this. Using promises, you can write consecutive asynchronous tasks cleanly in this way.
Indeed, it seems tidier than callback hell. But this is just a single code, is it not? It feels like making a word too long, and I think it might get a headache if complex tasks are added.
Yes, this method chaining is also disjointed from the general coding style. What was introduced to use promise more intuitively is exactly async and await. The functions on the left have the same code as the promise example. Each creates and returns an instance of promise. The part that changes is how to call them.
Besides the await attached here, it looks the same as synchronous code, right?
Yes, although the code has become longer than the previous method chaining example, it will be more intuitive to read. This method can only be used in functions with the async keyword attached, or at the top scope of Node.js's ESM. Await stops the progress of the code until the promise operation that follows is completed, and then returns the result. In other words, it allows you to code as if this process is a time-consuming synchronous process. In the case of this code, the string value that the promise returned by fetch data puts out after finishing the work is stored in the previous constant. This value is passed to the promise of process data, and then the value is retrieved by waiting for the asynchronous operation to be completed with await, and finally it is passed to save data again. After waiting for the operation to be completed, the value to be printed upon success is retrieved and assigned to a constant. In these processes, await plays a role in stopping the next code from being executed while asynchronous work is being done, like the stop sign of a school bus. After all processes have ended, if the save operation succeeds, it will be printed as console logs like this, and if it fails, the code of the catch block will be executed like this. Finally, through the finally block, it executes what needs to be performed, both on success and failure. This is how you can conveniently write JavaScript's asynchronous code as if it were synchronous code by using promise, async, and await. They are not easy concepts, so in order to understand and use them correctly in practice, you will need to watch the video repeatedly and practice with example codes. Then we will see you in the next content.